In the previous examples, what we've seen applying the mirror equations to a concave mirror. Now let's see what's going to happen when we apply it to a convex mirror. So a convex mirror has a focal length of 2 meters, and the object is going to be 4 meters from the mirror. Calculate the image distance, the magnification, and describe the image. Now, we got to be kind of clever here. So let's write a few things down, right? So we know that the distance of the object is going to be 4 meters. We know that the focal length is going to be 2 meters. But we got to be kind of clever here, because we're on either side of the mirror. We're on either side of the mirror. And therefore, one of these is going to have to be negative. One of these is going to have to be negative. It doesn't matter which one you want to choose. The way I'm looking at this side happens to be negative there. So I'm going to write the focal length as a minus 2 meters, because if I call this 0, the direction in which I'm looking at it, this is going to be negative. Now for you folks, it may actually be positive. So it doesn't matter. As long as one of these is going to be negative, it really doesn't necessarily matter which one's going to be negative. But I chose the focal length to be negative. Therefore, our distance of the image, the inverse of that, is going to be 1 over the focal length minus 1 over the distance of the object. Now, this becomes 1 over the distance of the image is equal to 1 over a negative 2 meters minus, now this becomes 1 over 4 meters. This is equal to a negative 3/4. It's a negative 3/4. Therefore, our distance of the image is going to be a negative 4/3 of a meter. Or we can say this is equal to a negative 1.3 meters. Now, because this is negative, because that's negative, this is going to be a virtual image. It's going to be a virtual image. Now, let's look at the magnification, all right? So the magnification is going to be equal to the negative of the distance of the image over the distance of the object, is going to be our magnification. Therefore, let's start plugging in the numbers we have. So this is going to be a negative 1.3 meters. Our distance of the object is going to be 4.0 meters. Therefore, this is equal to a positive 0.33, because this negative and that negative cancel themselves out, and therefore it becomes positive. Now, because this is positive, this is going to be an upright image. Because this is less than 1, this is now going to be smaller than the object. So we're going to have a virtual, upright, smaller image compared to the object. And so our image is going to occur somewhere over in this part. And it's going to be, it'll be somewhere, I'd say, let's see, that'd be 1, somewhere around there, and it's going to be pointing down, is where the image is going to, it's upright, I don't know why I have it going down. It's going to be upright, I'm sorry. It's going to be upright, and it's going to be about 1/3 the size of this, and it's going to be 1.3 meters from our vertex there. So this, you can apply the mirror equations to convex mirrors. If you have any questions on the mirror equation, let me know.